Hi folks, Shub here. I hear from a lot of people and they tell me that connecting to production apps should be easy, but it's not. So we at ngrok fix that. Ngrok creates a simple, unified approach to connectivity that works everywhere, from your laptop to production Kubernetes across multiple clouds. Instead of managing different setups for each environment, ngrok provides agents for everything. Native binaries, Docker containers, SDKs for multiple languages, and a Kubernetes operator. When connected, these agents deliver consistent capabilities: HTTPS, TCP, and TLS endpoints, DDoS protection, global load balancing and observability across all your environments. For production, we use bot users as service accounts with dedicated credentials, an auth token for connecting, and an API key for management. This keeps access independent from individual team members, creating proper security boundaries. Now, let me show you how this works with a simple Python service running on my local computer. It's called Alamo. It returns the name of the city, Alamo, and its cloud location. In this case, laptop, and is running on port 80. Using a simple ngrok configuration file, with the bot token and the endpoint definition mapping a domain to my port 80, we can deploy on a single command, and just like that, we have a public endpoint running at alamo.ngrok.app. If we go back to the ngrok dashboard, we can see the endpoint details, perfect for audit trails and security governance. Now, let's make it smarter by controlling traffic. With a simple YAML or JSON document with a set of phases, actions, and rules, we can define a 10 requests per 60 seconds traffic policy. Let's deploy it again and review it in the ngrok dashboard. As you can see, the policy is successfully in place. So now, let's test it by visiting our app and sending 10 consecutive requests. As you can see, the policy is enforcing traffic based on the rules we defined. If you want to monitor what's happening with your endpoint traffic, the traffic inspector allows you to see every request with complete details: headers, body, path, client IP. We can even replay requests for testing, giving us full observability. Now, let's take this to production scale. I installed the ngrok Kubernetes operator in our AWS Kubernetes cluster using the ngrok Helm chart. Let's check its status. We can see the agent and manager operators are running. In this cluster, we also have the same Alamo service deployed, but this one returns AWS as its cloud location. Let's create an agent endpoint for it using the endpoint CRD, providing a different URL. In this case, alamo-aws.ngrok.app. With the agent endpoint deployed, we can see it on the ngrok dashboard, and we can confirm the app is correctly working on the defined URL and returns the expected payload. Now, let's add something more sophisticated: a debugging rule that evaluates if the request URL has a query parameter debug equals 1. It will then return a 200 status code with debugging information. What you are seeing in the body is called cell interpolation, allowing us to dynamically include connection, request, or response details in traffic policy actions by embedding variables and expressions. This might seem simple, but it's foundational, because we can use any of this information to make routing decisions, transform requests, or customize responses, all without touching our application code. Remember our laptop endpoint? It's still alive. But watch what happens when I change the AWS endpoint to use the same URL. Now, requests automatically load balance between the laptop and AWS. This is called endpoint pooling. To do this, we didn't need any complex setup. We didn't need external load balancers, DNS changes, or cloud-specific networking. Just start another agent, and it joins the pool. Each instance still maintains its own traffic policy, even though they share an endpoint URL. If we stop the laptop agent, the endpoint disappears from the dashboard and won't be part of the endpoint pool anymore, because agent endpoints are connected to the lifetime of the agent. This is where cloud endpoints become crucial. Let me create one in the dashboard. Cloud endpoints are persistent resources managed centrally through the dashboard or API, and they exist until explicitly deleted. They can serve content directly from the edge with no backend calls necessary. Let's enhance our cloud endpoint to route traffic intelligently. Our cloud endpoint routes traffic by path. /Alamo forwards to our AWS internal endpoint, and /Bronx forwards to our Azure internal endpoint. Each service team manages their own policies independently. AWS has rate limiting and debug parameters, while Azure checks JWT scopes to control read-write access. Let's add security at the edge by implementing OAuth. Now, all requests require authentication first, with identity flowing consistently to all services. We can even restrict access to specific email domains and validate JWT tokens with service-specific claims. Now for the ultimate test. What happens when AWS goes down? We've configured AWS to fail over to GCP if there's an issue. Watch what happens when a user makes 7 requests, then AWS fails. Traffic automatically routes to GCP, but amazingly, the rate limit count continues across clouds. After 3 more requests, they're rate limited, exactly as it should be. We've built the most robust connectivity layer that works across any cloud anywhere, secures every request at the edge, maintains policies even during failures, provides complete observability, all without changing a single line of application code. Stop dealing with infrastructure. Start building what matters.